Hello, hello. Welcome. Okay, this is you're joining me on my very first night of live streaming. We are going to make an AI art generator from scratch using just CUDA libraries and the standard library. And among CUDA libraries, we won't use any deep learning libraries. We're going to code all of the low-level functionality of a deep learning training process and neural network implementation ourselves. So let's get started. We'll start with installation. So this is how we'll have all the tools we need by the end of this. So this might take a little while. First off, we'll get Visual Studio Code. Okay, I'm on Windows. Every tool I'm about to install works on Linux. They work well. I've used all of them on Linux before. It's very similar between Linux and Windows. I'm just using Windows because I like Windows a lot. And I've seen better CUDA error messages on Windows. Haven't looked into why that is. Download VS Code. We'll start with VS Code. The other tools kind of take a while, so we can be on VS Code and configure that while we get our other tools downloaded, installation started. We definitely want to start menu folder. No desktop icon. Open with code action. Yes. Yeah, file context and directory context. Supported file types, that'd be good, and path, we want that. Okay. 1 second. Just trying to see if I get any chat messages coming in. My other computer. All right, we'll go ahead and launch VS Code. I've already had it installed, so it actually saved the last text file I had open before I uninstalled it. That's interesting. Oh, well, I uninstalled it, reinstalled it, and all my extensions are back. I've used all of these extensions. So I'll just go over which ones we'll need for this project, or that I recommend at least. Delete these error messages. Better comments is really good. The way you get to the extensions, it'll be here on the left. I have some extra icons here because I have other extensions installed. You can get to it by just holding down Control-Shift-X. And boom, opens extensions. So I'll do that again. Here's like a file explorer, essentially, where you can explore your project. We don't have a folder open. We'll do that later. This search will search within the entire directory that you have open. And if it's just one file you have open, it'll only search within that one. Unless you have a directory open, then it'll search everywhere. So yeah, from any menu we're in, or even if we're in a new file, Control-Shift-X, we want the C++ extension by Microsoft. So you come over here, click enable or install. The extension pack installs a bunch of extensions, but we don't need all of those. Okay, then next, there's one CMake. There's a one that Microsoft makes, so that's the, oh, let's enable it. That's the one, that's the good one. This one's like really not that great. We'll want a CUDA extension. Where's our, oh, here we go. Insight Visual Studio Code Edition. So you would hit install here. Yeah, I'll show you guys what it looks like if you don't have it installed. Install. It's pretty quick. This will let you navigate through your CUDA code the way you can with the C++ extension and navigate through regular C++ files. In case you don't know, CUDA is a way to program your GPU so you can run your code directly on your graphics card. The way a graphics card runs code is a bit different than a CPU would. So it's got like some custom calls, custom syntax that goes along with it. With CUDA, there's a few languages that they have APIs for. I'd say they're more than API because they add syntax and keywords to the language. But I'll be doing a lot of CUDA coding. There's CUDA available for C++, C, Fortran. I don't know about Python. Might be a few others, but those are the big ones. I know you can link in CUDA to run through Python. I don't know if you have to write the CUDA in C and then build a library and then call it through Python. However, Python bounds to C. That might be how you have to do it. Maybe it can be written directly in Python. I'm not, haven't used Python much, so I don't know. Then we'll want to Git tools. So Git lens is awesome. I'll reload. You don't have to reload. I just had to reload because I uninstalled and reinstalled it. A fresh install won't need that. Git lens. It's a great tool, especially good for looking at diffs between different commits. And of course, I'll be uploading this code to GitHub, so we'll get this official GitHub pull requested issues. I've never seen this switch to pre-release version, but I'm sure it'll work fine. Okay, next is to-do tree. This one's great. It'll go through your code, and anywhere there's a to-do in it, it will highlight it so you can see it. And then what it does is it creates like a new icon on the left-hand pane here. And anywhere in your code, it'll list the file name and all the to-dos and any text that comes after the to-do. There's a few others we might use, but I'll install those as we use them. Oh, here's another one. Number monger. This one's sweet. Okay, check this out. So in Visual Studio Code, this is what you can do just by default is you hold Alt-Shift, click anywhere on your screen, and now you have what's called a block select. So when you type things in, it types on all of the lines for you. And you might have a number of signals that you have. You actually might do something like this in CUDA. I know you're probably thinking that, oh, in C++ you just create an array. That's obvious. But in CUDA, there's actually reasons to do this. You can't create arrays on the stack. So in the stack is the fastest. The stack goes into the L1 cache on NVIDIA graphics cards. So it's actually better to make all of the variables that you have individual and not an array. So signal number, this is where the magic happens with number monger. Let me make sure I have it installed and it's enabled. Yep. Okay, back to the file. Control-Shift-P to open up the settings. And I think, what is it? A sequence, I think is how you would call it. Yep, insert sequence. And you can start it at any number you want. So just for sake of example, start it at 4. Step size we'll do 3. I don't remember what right align does. 0 pad, yes, we want to 0 pad it typically. Boom. Now it starts at 4, goes up by 3, all the way. This is really useful all the time. Like, just I use this all the time. I use other programs, like I might use Excel and then transfer in something as a CSV, do that operation, and transfer it back to an Excel file. It's really useful. Okay, so the next tool we'll get is Visual Studio Community. Visual Studio is a great IDE. It's way better than Eclipse. I've used Eclipse a lot. But Visual Studio Code, it's open source, it's by Microsoft. It's got so many additional great extensions put onto it. It must have some kind of like great extension creation API on it. That every company I've been to so far, almost everybody switched to VS Code. There's also, for people that are into Vim, which I am not, I respect those that are. This program has a Vim emulator, so you can use, I don't think every keyboard shortcut, but most of them. Okay, we'll do community. The reason we're using Visual Studio is because it comes with a compiler that works on Windows. And then we can have the CUDA compiler works with the Visual Studio one, MSVC. You have to have Visual Studio installed before you install CUDA, the CUDA compiler. So we're going to be waiting a little bit for this to install. We're doing CUDA C++. So before we install CUDA, we need Visual Studio and the C++ extension. We need any of this. We can always come back and install more things. Oh, I'm going to install this for myself. You don't need this. All right, so here we go. You might have to open Visual Studio 2 before you install CUDA, but it won't hurt, so better safe than sorry. Okay, next we'll be downloading CMake. CMake is a tool that helps the compiler know where all of your code files are and find all of them and compile them and link them all together. It also, you can put like define statements in, you can do preprocessor things through CMake. This one is very much used in industry as well. The use CMake, it generates a make file, which does everything I just said. And then you run them, after you run CMake, you get your make file, then you run the make file. The problem with make files is they're pretty unreadable. CMake's a lot easier to learn, it's more intuitive. So download for Windows. We don't need the source. 3.25. Oh, coming out with newer ones all the time. It's reverse compatible. So if you have a project that was built with CMake 3.13, for instance, this 3.25 will be able to generate your makefile for you. Makefile is usually what you target. You can also generate Ninja build files, but we'll do make. Make's more common. Ninja's faster though. You can probably tell by the name. Next, accept. Yes, we'll add it to the path. Default's a no, but we want it on the path, that's for sure. That was just my system prompting me to click yes for admin permissions for the install. Let's check that and put it on the path. So I just, you can't see because it's off screen, but I hit the Windows key so that the pane pops up. Then I just typed in environment. Well, you can just type in environment. And it should say edit the system environment variables, hit enter. And then this pops up for you. So it pops up straight to the advanced tab. Click environment variables, and on this is the one that should have it. I don't see it. Path variable. Maybe it's under system variables. No, it's not here. Well, let's see if it works. Okay, so I'm gonna open the command prompt, hit the Windows key, just CMD, enter. So it should be able to find that executable, because it should be able to, it should have its path listed somewhere, and then -- version will just tell us the version it is. Oh, it can find it even though it's not in here. I don't know how that works. Oh, we got it installed. That's good. Visual Studio's almost done. All right, next we'll install Git for Windows. So I'll slow down a little bit. Okay, so you go to Google, just type in Git, hit enter, click download for Windows. And we want 64-bit Git. We will get the setup, not the portable. I think that'll give us more options. I mean, more tools. Admin permissions. This is our first screen. There's a lot of tools that come with Git. So I uninstalled Git already, so I'm reinstalling it. That's why I'm getting this. You shouldn't see this. I don't like my icons on the desktop. I would just hit the Windows key and then type in the name of the program. So no, not on the desktop. Windows Explorer integration, yes, please. Don't have to check for updates. So I'm just leaving all these as default. Okay, so next. Default is good here. Next. Let's just use vscode as Git's default editor. Oh yeah, there. Yeah, the default Git was written by the guy that wrote Linux, Linus Torvalds, and he made the default branch name master. But yeah, that's kind of weird because it's like people don't want to be reminded of slavery in the middle of their workday like 15 times. Yeah, main's a good default branch name. I don't know why they say it's a more inclusive name. I don't think most people want to be reminded of slavery. Get it from the command line. Yeah, we want to be able to use Git from their Windows command prompt. Yeah, we want to use this. There's a lot of instructions and stuff online on how to use OpenSSH. I don't know the difference between these. I'll go with the default. Commit Unix styles, that's fine. Okay, yeah, we'll use minTTY. There's a new Windows terminal. Or command prompt. That came with Windows 11. You can install it on Windows. I hope it's a lot better. I know it's got tabs at least, but there's some other things I could improve. Haven't looked into it. Okay, we'll do default git pull. Okay, that's done. Yeah, I don't really know what those last few options were. If anybody could add in the comments or into the chat what their personal favorite is. I'd appreciate that. All right, we'll launch it. No release notes. All right, we've got it installed. Looks like it's up to date. Visual Studio here. Let's open it up. I need to change this so you guys can see my Windows pane. When I hit the Windows key, I just type in Visual Studio. The installer is the one that pops up. So you can hit space 2022, and then now I have selected Visual Studio 2022. So I'll open that up. We're just doing this to make sure it's initialized properly. That might be necessary for the CUDA installs. Oh, sign in. So you have to have a Microsoft account, but you can use Gmail to do that. So that's convenient for me. And that's why my keyboard's out of frame for my password. All right, it's opened up. And I had it uninstalled. I just reinstalled it. I've got a few projects already. And that's the last we'll deal with that. Oh, yeah, that plus, so for vscode, let's pin that to the taskbar. All right, now our last tool is CUDA. This is a big download. So 12.0 should be the latest one. Let's see if we need an account. I have a NVIDIA account, so we'll be fine. So Windows 10. I'll just do a local install. 3.4 gigabytes to software folder and open upon completion. Damn! I love these high speeds. So you can open up the terminal while we download this. We'll go over VS Code somewhere. VS Code, hold down Control and you press the tilde. That's the just left of the one. Well, I guess you would hold Shift for tilde, but so it's the accent aigu. So Control accent aigu, and then the terminal pops up. And this is the same. Oh, this is a PowerShell terminal actually by default now, which is similar to the command prompt. It's got more functionality. I haven't used PowerShell much, but I know that much. So let's see if we got Git. Yes, we have Git. That's good. I don't know what window dialog means. All right, let's open it. It was set to auto open. That must have been what that window dialog was. Here we go. Okay, user account control. Oh, I clicked it twice, so it came up twice. So I just hit yes once and then no. Okay, yeah, temp path to put all the CUDA files. All right, the floating screen's up. Here we go. Don't need these anymore. Alright, this is taking a while. Let's get back to the software stuff. Multitasking time. So me under my... Sorry, I'm nothing too illegal over here. Okay, we're good. Under my home folder, which I named Mick H. I'll let you guess what that stands for. I have a repos folder, and in that I have my various repos. So let's get started and we'll make our directory structure for our project. What should we name it? This will be the name of the repo for it. AI art generator. Sounds good. Alright, F2 to rename. I'm just highlighting it to copy it. Enter. New folder, Control Shift N, Control V, put the name back in. Okay, so this will be our root directory, and I like to put my source in a folder that's the same name of the repo. And then here I would have like my main file, and then a bunch of different directories for however I want to categorize all of our other files that we'll tie together. So I know, for instance, I'll have a folder for utilities that I make. We can just make our main.cpp file. And this will get full pretty soon. Okay, now to use CMake, we need to make a text file, and we have no control over this. It must be named CMakeLists.txt, and I'm pretty sure it's case sensitive, so that's capital C, capital M, AKE, capital LISTS.txt. That's, yeah, all we should need for now. There'll be some files generated when we make it into a Git. So actually, while we're still on this subject, we can open this in code now because we selected the directory explorer menu. Oh yeah, and if you want to know why my color theme looks so cool, I installed a theme. It's an extension you have to get. So Control-Shift-X, that allows this particular theme. Cyberpunk, that's what it is. So you install the Cyberpunk extension here, and then you Control-Shift-P to open the settings menu, color theme, and then activate Umbra protocols should come up. I really wish it didn't save all of my settings, so I could know for sure that's how you do it, but it's something like that. I'm just fixing these errors. Alright, agree and continue. Let's do custom. Let's see what we get. Yeah, we might need these drivers. Oh yeah, also I've got I'm using a gaming card like 99% of people versus like a workstation card like a Quadro or a server card like a Tesla. So you can use GeForce Experience. That'll keep your driver up to date. I don't know if they put in like a different driver if you use CUDA or not. USB-C driver. Why in the world do they have that? Oh, it's gonna install this GeForce Experience. It's not going to because I already have it, but it would. Yes, this is what we're looking for. vscode integration. Don't be brave and click it on and off like me. Just keep it on. Libraries. Oh, yeah, we want the visual profiler. We could be using that. And we want the samples. Oh, that's probably in the demo suite. You know, we're gonna do this all by hand. We don't even need to install these. Oh, we do need CUDA. We don't need the fast Fourier transforms and linear algebra. Where's QDNN? Get rid of that. Pooh, we're gonna do this like gangsters from the lowest level. As far as profiling goes, it's really good in regular Visual Studio. It's really weird. Microsoft named their IDE Visual Studio, and then they made a new text editor with like that extension API. They named that Visual Studio Code. So like Googling questions about either is a nightmare now. But usually I'll just try searching vscode on Google. A lot of people just start calling it that now to like clear up that confusion. I haven't used the profiling in VS Code. Okay, yeah, GPU and kernel state inspection. Sweet. That'll be great for debugging. Kernel breakpoints. Syntax highlighting is nice. It has new syntax beyond the standard C++. CUDA supports pretty much everything in C++ except for exceptions. And one of their engineers came out and said that like none of the big companies have even asked for exception support, so they're not bothering with it. Which is fine by me. Alright, it's gonna launch GeForce Experience, which I did have installed, so I didn't have any problems with it uninstalling and reinstalling it. And there's a driver update. I'll download. I'm not going to install it because that's going to mess up my stream. We'll make sure there's no problems with downloading. There we go. All right, and no, don't click it. Close. All right, here we go. So earlier we opened up, went to our folder, right click, open with code, and it's open. So just to test our program, first we'll just test C++, and we'll do CUDA. So let's write a quick little program. All right, that'll do it. We'll go to CMakeLists. This is a compatibility. The first line in every CMake file, you probably have comments, I don't know, but the first command, CMake minimum required. So this won't run if, because different, this could be transferred to different computers and they could have different versions of CMake. So you want to use the earliest version of CMake. So we have 3.25 installed, but you want to use the earliest version of CMake that could run your program, meaning like you don't have any new commands that are only in later versions. So CMake, they added a bunch of CUDA features in 3.17, and we want to use those. So we will use 3.17. So anyone on 3.17, 3.18, 3.19 will be able to run this. CMake language. So CXX, that's how they do C++. We're not going to do C. So we'll just, no, we're not going to do C. So just CXS XX for C++ and CUDA. All right, and then now we have our project name. So I always just name it what the repo's named. Project. Let me look up. I don't remember. I think it's add target. But we want to, we're not making a library. This is where we're telling it. Basically, we're going to make an executable here. Oh, there we go. Add executable. And I think it's like CMake project name. Yeah. Looks good. We got to add. Now we'll put in we've got to tell it which files we're compiling. So how do we do that again? Maybe it's an add executable. Let me double check. I got some other repos we can look at. Oh yeah, in the future we will make this so this is going on a Git repo. It'll be public so everyone can get it. I'm gonna make it cross-compatible with Linux. There's a huge advantage to Linux. There's no watchdog timer, meaning or there is one, but you can turn it off on Linux really easily. What that means is that like if you don't get a response from your GPU for 5 seconds or more on Windows, it'll like throw an error because it thinks that the graphics card is frozen. So it's trying to recover from that, which is great if you're gaming. But when we train the network, it's depending on how our algorithm will turn out to be. It's possible the GPU will do a lot of computation and not need any information from the CPU's RAM. So it could run for over 5 seconds without communicating back with the CPU. I've had this issue before. What I had to do is I would just transfer a single bool from the CPU to the GPU like every second. So like 1 byte. But I had to shut down all of my kernels, and then so then it has to end all of those threads, and then it has to like create a whole new context after sending the bool over, which isn't a big deal because it's once a second, right? It's not like once every for loop or so. But it made the code really messy, which I didn't like, having to stop my kernels like midway in some cases. And I had to do experimentation, like how far through the kernel could I get, and then it would change based on like how many threads I was using, like per block, and like how many total threads I was using across all blocks. So that's one advantage of Linux. Like I said, with Windows though, it tend to you get better error messages. I have no idea. It must be the drivers, but the NVIDIA drivers are closed sourced for gaming GPUs on Linux and Windows. So there's that's probably it's probably not gonna get any better for Linux with those error messages. Oh, we can put the languages. We put the languages in with the project name. Yeah, we don't need quotes with this. It's an executable, so I'll do. We're on Windows, so we'll do exe. Or wait, well, it'll probably automatically append exe since it's Windows. We'll see what happens. Okay, and we'll set our standards. We'll set the version of CXX we'll use, 17. That means C++ that was ratified by ISO in 2017. Same with CUDA. I think that just means it's a CUDA based off of C++ 17. We're not using OpenGL. We'll probably multi-thread. I'm not going to add anything in until we need it. Keep it clean. A lot of this is OpenGL stuff. Oh, and there's this GUI I was using in GUI for this other project. We won't use that yet if we do it all. We don't have any include directories yet. Oh, okay, this is how we do it. We just set sources. So set sources. Surprised they don't have a better, like a specific function for this. Maybe they do now. If there's a newer function, I would use that one. So we can look that up later. Here's where our file is. It's our only source file. What else we got here? Looks like we add the executable after setting our sources. That makes sense now that this sources is the oh yeah, after our sources variable is defined. Let's indent that. Yeah, so this would be a list if we had multiple lines of it, but it's just one line, so it's a typical variable. So I guess we could just put our sources here, like we could just list them out afterwards, but that's ugly. That must be why it's set like this. I still wish they had like a specific function for adding sources though. Okay, and then this means call what this variable is. This variable is set by the project command. This is anything that starts with like never name your variable starting with capitalized CMake underscore. These are because all of the reserved, not all of them, but most of the reserved keywords that CMake uses is prefended by that. Here's target sources. Okay, so I guess we could just use this to add in our files here. I'll get better at talking and coding. I've seen practice. Private. I don't know what private means, but we need it. So we'll comment that out, see if this works. We're not linking any libraries yet. The standard library is automatically linked in. This the DL, that's for dynamic linking. We don't need that. And multi-threading, this is a Linux windowing system. That's why it's the if Unix. But this doesn't have an if Unix. CMake has built-in functionality to find like all of your OpenGL libraries on your system if your system's supported. So I imagine that's Windows and Linux. Does Mac even support OpenGL anymore? I think I heard they don't. Oh yeah, okay, we want this in here just for reference later. We're not using our language C. So we'll delete the C section. don't want a C section. We want naturally implemented code. So here is where I could put in all my compiler settings that I would want to put in. We'll just delete all of these for now. And then not use any. We'll add them as we need them. Okay, we can specify specifically the CUDA architectures we want to compile before. When CUDA is compiled, it's compiled into a pseudo assembly language. And then it passes all of it, and so it takes out all the CUDA code, and then converts it to like the pseudo assembly language, and then it passes on the rest of this C++ code to the C++ compiler. And on initialization of the program, it passes that pseudo assembly code to the driver, and then the driver has its own compiler that actually compiles it to real like instructions, like machine instructions for the GPU to run. I think if you set these specific architectures though, it'll not compile it to ptax and just straight to the NVIDIA machine code. But we don't need that. Separate compilation, I don't remember what that means. Oh, and then we can set to if we debug is something that we can pass in when we run CMake. And so, for instance, so we could pass in debug and then make our CUDA language have the debug options. The capital G is debug for the CUDA compiler, which is NVCC. I think that's NVIDIA CUDA compiler. Okay, but we don't need to do that. So